All right, example 5 is the application problem of section 2.3. The demand for a new smartphone can be modeled by, let me highlight this function they gave us. P of x equals 575 minus 45 natural log of x, where P of x is the price consumers will pay in dollars and x is the number of phones sold in thousands. Okay, so the price will depend on the number of phones sold. Okay. Recall that the total revenue is given by revenue equals x times, x is the number of phones being sold, times the price. Okay, so they said find R of x. Well, they gave us what P of x is already, so we can easily find R of x. R of x, the total revenue is x times P of x. I'll just do this in two lines. That is x times 575 minus 45 times natural log of x. So that is a total revenue function. And if you want to distribute it, you can make this as 575x minus 45x natural log of x. That's good. All right, so what do they want this time? Let me go ahead and put the R of x everywhere. So find the marginal revenue R prime of x. Now we have to take the derivative of this. I kind of want to, I guess both are fine. Both are fine. Both this equation and that equation is fine. I wonder how our book did it. But we need to just find the derivative of this. Note, marginal revenue is the increase in revenue that results from the sale of one additional unit of output. Okay, so we can find the derivative for them and we can probably answer these application problems. So what is R prime of x? That is going to be, and I'll just use the last line down, okay? I need to take the derivative of 575x, right? That's the first term. And then I need to subtract that by the derivative of 45x times natural log of x. All right, let's do one thing at a time. So first term, what is the derivative of 575x? Well, that is going to be just 575. That's super easy. I may need some more room here, but for the second part, I would like to use the product rule. Okay, I'll put the minus sign here, and I will put my product rule pieces inside this gigantic parenthesis, okay? I wonder if it's big enough yet, but you know why I'm doing product rule? Let me show you why I'm doing it, because I see pieces. Product rule. Okay, here I have first function to be, hey, how about we pull this 45 out to the front? We can do that, right? That's just a constant. That will make it a little bit easier. Hold on. So I will have the 45 outside. Okay, and I will just find the derivative of x times natural log of x. Okay? So I will go ahead and write the 45 outside. And get rid of the 45 inside. Many of you are doing this on your first test. So I was like, why not? You guys are doing it. I want to do that too. So that's okay. We can pull that constant out and just multiply by 45 when we are done. So everything okay so far, right? So f is just x. Just x. Derivative of x is 1. Now, what about g? G is natural log of x, right? Then g prime is, we know that, 1 over x. Alrighty, let's use the product rule then. Since I'm out of room, I'll just go ahead and, you know what, I will write it down. fg prime plus gf prime. So what do we need first? First times, I need x times the derivative of the second, 1 over x. Oh, look, something interesting will happen. Plus second times natural log of x, the derivative of first, which is just 1. That's going to be nice. All right, zooming out, let's go ahead and write down what we have left then. 575 minus 45, we got pulled out to the front. But if you look at this, x cancels out with 1 over x. So that is just going to give you 1, right? X times 1 over x, guys, is 1. That's why I have to have the x 1 right there. And then I need my plus sign. And natural log of x times 1 is just natural log of x. So we found the marginal revenue function by taking the derivative. I hope I get to use it. All right, let's take a look. Part C. How many units will be sold if the price that consumers are willing to pay is $550? Why are they making... This isn't about marginal revenue here. This is just asking us to use the P of X function. Kind of boring. All right. So they said P of X is P is equal to $550. And they're asking us to find how many units. So we're not going to use the marginal revenue function, the way that it is worded. We're just going to go ahead and use the function they gave us, where P of X was 575 minus 45 times natural log of x, okay? And what I'm going to do is I will set this function equals to 550 and solve for the x. How many phones is being produced or being sold if people are willing to pay $550. So let's solve this. First, subtract 575 from both sides. If my math is right, it's been a long day, you guys. I will get negative 25 equals negative 45 natural log of x. All right, I will divide both sides by negative 45 now. Negative divided by negative will give me positive, and it looks like we can simplify that fraction to 5 over 9. And that equals natural log of x. And in order to solve this for x, we will need to rewrite this in exponential form, right? So what's the exponential form? Base is e, power is 5 over 9, and that equals x. I'm going to go ahead and type this into my scientific calculator, okay? So, hold on. I don't like the way it's written. I'll say x is equal to e raised to the 5 over 9th power. And this is, this is approximately, we need a calculator, right? All right. Here you go. Let me retype this. E raised to the 5 over 9 is approximately, I'm sorry, 1.7429. But I want you to remember something. What they said about the x value. X values were, let me go scroll up and show you where they said it. Where did that go? Right here. I'm gonna zoom in like crazy. Okay, you see that part? X is the number of phones sold in thousands. You see that? X is the number of phones sold in thousands. So this decimal is not saying that they made 1.742 phones. They're not making like less than 2 phones and people are willing to pay $550 for it. So what we need to do is, because this number is in thousands, I will now need to multiply my answer by this decimal by 1,000. Okay, and I'll literally just do it over here. This is getting multiplied by 1,000. Okay, so my answer is this. We're talking about phone here, so it makes sense for me to round up to a nearest whole number. I wonder though, should we round down? Because will you count 0.9, like a 90% of a device to be a phone. Maybe I shouldn't. Maybe I should just give them the whole. Whoopsie! I dropped my Apple Pencil. Hold on, let me go grab it. Dilemma now, because I'm like, should I round up? I would usually round up. But if I write the decimal first, it was 1 point. Let me show you what I'm writing down. It was 1.7429, but we need to multiply by 1,000. Okay, that's why we got that answer, guys. All right, let me put this back up here. We're almost done with this problem. And the reason is because X was number of phones sold in thousands. That's why I need to multiply by 1,000. So down here, the answer is, I will say 1,740. I'll round up. Oh, okay, I'll round up. 1,743 phones. That will be my answer. And I kind of wanted to round down because we're talking about a whole phone here. So I wouldn't count a 90% completed device to be a whole phone yet. I don't want that phone. But I just rounded up because the next number was 9 and I was just tempted to. I wonder what the textbook will say. I'll go and check it in my lab because we have access to e-textbook. I think I got this from the textbook. But that is how you will answer this question. And I'm kind of bummed because we did not get to use the marginal revenue function that we found in part B. But hey, maybe the next example will let us do that. So I will stop this video now and we'll be back with example 6 shortly.